Hello everybody, we are starting day 4. So our learning target says given a parabola, I can identify the number of real solutions and the solutions, and I can find the solutions of a polynomial by graphing. So as you should see, that is new for us today. So we have the same graphic organizer at the front. So method 1 is factoring. So I just did an example and hopefully you should feel confident solving it as well. Efficient, I get my two solutions, 2 lines of work. But what happens if I told you to solve 6x squared minus 29x minus 5 equals 0? Because as of right now, the only way we know is factoring. But I may be asking, I may be asking myself, how do I get a 3x? I need 2 numbers that multiply to 5. I also could have a 6x and an x, a 1 and a 5, or a 5 and a 1, 1 and a 5 and a 1. And you're sitting there trying to factor it into 2 binomials and it doesn't work. And that's possible because not every quadratic factors, okay? It still has 2 solutions by the fundamental theorem of algebra, my favorite theorem. But we're going to have 2 solutions, but factoring doesn't always work, okay? Doesn't always work, okay? And so that's why, as we move through here, we're going to have 3 more methods that are going to help us be able to solve this. So by the end of today's notes, you should be able to take this quadratic 6x squared minus 29x minus 5 and be able to solve it by graphing, okay? I will also like to note, normally we'd use our graphing calculator and Desmos, but because I'm not with you, I'm going to show you everything using Desmos, okay? Okay, so to get our brains activated, we're going to go to example 1. And it says solve the following quadratics by factoring. So for A, B, and C that I highlighted in yellow, I want you to check your understanding. And if we were in class, I'd give you about 2 minutes to do this. I want you to solve those 3 quadratics by factoring. And then pause the video to do that, and then unpause when you're ready to check. Okay, so we should check our answers for A, B, and C. The one thing I want to note on C is sometimes I'm noticing on our homework that when we factor, we end up with opposite signs. So we want to be careful and really pay attention to those 2 signs, because remember, I want to add to -3 and I want to multiply to -10. So again, I'm going to write this down. We want to sum to -3x and we want to multiply to -10. So if we were using the diamond math method, multiplying to -10, summing to -3, so that's why I'd have a -5 and 2 as my 2 factors. So if you're finding that your answers are ending up opposite of the correct answer, that's probably what's happening. Okay, so here's the big idea of the lesson that I want you to focus on. So what I did is I took x squared minus 9, so this function, and I graphed it, okay? And now the big idea is when I graph it, I want you to take a note at what you notice as the x-intercepts. So my x-intercepts is where it crosses the x-axis, right, which is right here, okay? And I would assume when you look at those, we have a 3 and a -3. And so my x-intercepts are -3 and 3. And I hope you're recognizing a pattern. So the next one, I graphed y equals x squared plus 4x plus 4, and I only had 1 x-intercept, but it was -2, okay? So I have x equals -2. The next one, graph the quadratic. I have an x-intercept right here of 5 and an x-intercept of -2, okay? And so big idea is, what relationship do you notice between the solutions and the x-intercepts? And hopefully right now at home you're saying they're the same, which they are. They are the same, okay? And so I know I kind of revealed this in some factoring notes, but the solutions and the x-intercepts are the same. So we can solve by graphing by looking at the x-intercepts. Okay, and some of these words are interchangeable. So x-intercepts is the same thing as solutions, which is the same thing as zeros. Okay, so these words, solution, x-intercept, zero. Oop, I got another one. Roots. These are all the same. These words are interchangeable. They all mean the same thing. Okay? So here's your check for understanding on the first concept. So it says identify the solutions of each polynomial function. Assume each unit is 1. So I'm going to do one with us. I'm going to do letter, I'll do letter E. Okay, so I see a parabola. Oh, that tells me I should have a quadratic. Okay, and my x-intercept, 1, 2, 3, 4, 5, I think it's a 6 we can go with. Okay, my x-intercept is 6. Now notice it's called a bounce. What happens is my function comes down, I have one of them, and it goes back up. So some students prefer to write 6 and 6 because they want to make the connection that they know that quadratics, and we know it's a quadratic because it's the shape of a parabola, have 2 solutions. So if I asked you to list the real solutions, we would say x equals 6 and 6. Okay, and then if we were to write the equation of it, I can write y equals, now if I had a solution of 6, that means my binomial would be x minus 6. Excuse me. And I know I have another root of 6, x minus 6. So that would be an equation. Now you could also, if you wanted, multiply it out and write y equals x squared minus 12x plus 36, which I got from foiling that out. I just didn't show all steps. So what I want you guys to do for the remaining 5 is to pause the video, and I want you to just write down the x-intercepts and the real solutions. They should be the exact same answer. And unpause the video to check your answers when you're ready. Okay, so when you're ready, you can check your answers. I do want to pay particular attention to B and D, which is, I'm assuming, where the majority of our questions came from. So for B and D, the first thing to notice is that we have a parabola, right? And so I'm going to walk you through my thought process. So I know a parabola always has 2 solutions, right? Because it's a quadratic, and quadratics have 2 solutions. The next piece is we're always looking for our x-intercepts, but on both B and D, the quadratic does not cross the x-axis, okay? And so here's the deal. Our x-axis is where our real solutions are located. Okay, so the idea is, okay, so I know there's 2 solutions and it doesn't cross the x-axis, so there's not real solutions. It means there's actually 2 imaginary solutions, okay? So you don't need to write this down, but it's important to know that this means that we're going to have different types of solutions. So again, there's 2 imaginary. Okay. How to find imaginary solutions is something you'll learn in Algebra 2. So for right now, we would just say no real solutions. So the next piece is following on the idea of what I just talked about, which is that real solutions equal our x-intercept. So we're going to sketch some graphs where I'm going to have 2 real solutions, 1 real, which is what we're going to call a double root, and 0 real solutions, okay? Now, again, quadratics always have 2 solutions, okay? But they can be real or imaginary, okay? So again, in Algebra 1, we're focusing on the real solutions. So if I said sketch a graph that has 2 real solutions, my graph should be a parabola because it's a quadratic, okay? And so 2 real solutions, here's an example. I'd have 1 or 2. Maybe I wanted to do a different one, put my vertex positive. I would have 2 real solutions. Big idea. How many x-intercepts do I have? 2. Okay. Next, what about 1 real solution? So that means I'm going to have the same answer twice. So that means that my vertex has to be on the x-axis. Okay? It's a parabola, which is a quadratic, which means we have 2 solutions. Okay? But the key here is the vertex is on the x-axis. Okay, so I would have one x-intercept. So this is an example. If we just, so you would x squared plus 4x plus 4 equals 0. If you were to graph that, we'd get x plus 2x plus 2 equals 0. So if we were to solve it by factoring, you'd get the -2 and -2, which on a graph you'd see, oh, this worked out well, you'd see a graph something like that, where the vertex is on x-axis, you know, if this was -2. Okay, and if I had 0 real solutions, so again, that would mean there's 2 imaginary, my vertex would never cross, not my vertex, my whole parabola would never cross the x-axis. So if I had my vertex here, I'd have to open down. I also could, you know, put my vertex right here and open up. Okay, but it would never cross the x-axis. So one thing I think is silly is sometimes kids will, here's a graph, and they'll say, oh, it doesn't cross. Well, of course it does. You just didn't, your arrows didn't continue. I mean, this is not an example because it does not work. So just make sure it either opens up or below the x-axis. Okay, and how many x-intercepts would I have? 0. Okay, so again, I want you to see the correlation between 2 real solutions means I have 2 x-intercepts. 1 real solution means I have 1 x-intercept. 0 real solutions mean I have 0 x-intercepts. So those words have a direct correlation to each other. Okay, and if I talk to you about other types of polynomials, so what if I said graph a cubic with 3 real solutions? That just means we'd have a cubic with 3 x-intercepts. So maybe something like that. So I'd have 1 solution, 2, 3. Or a 4th degree. So 4th degrees look like W's. So if I go like that, 1, 2, 3, 4. Okay? So again, to conclude, big ideas. Solutions, I should say real solutions, equal our x-intercepts. Okay, and that's really where we're at right now. Okay, so the next video is going to talk us through how to find our solutions and actually solve quadratics by graphing.